We now move from architecture vision into architecture detail. In phases B, C, and D, we compare current and target business, data, application, and technology states, identify gaps, and shape the Azure-based secure enterprise AI platform. So far, we've built the foundation: enterprise architecture value, TOGAF concepts, principles, stakeholders, and the Azure AI case. We then explored the ADM, architecture capability, and the Phase A vision. The next step is to turn intent into detailed target architectures across the business, data, application, and technology domains. After that, artifacts will make the work practical and exam-ready. Once the architecture vision is approved, the work shifts from direction to design. Phase A clarified the business reason and high-level outcome. Phases B, C, and D translate that intent into business, data, application, and technology architectures. In each domain, architects compare the current baseline with the desired target, then identify the gaps to close. This is not a simple handoff from one phase to the next. A data decision may affect an application assumption, and a technology constraint may reshape a business design. The output feeds the architecture definition document, roadmap content, and migration planning. Across phases B, C, and D, the domain changes, but the working pattern stays consistent. First, understand the baseline: the capabilities, systems, data, technologies, constraints, and pain points that exist today. Then define the target: the future state that supports business outcomes and follows architecture principles. Next, analyze the gaps, including what must be changed, added, retired, consolidated, or improved. Finally, capture architecture building blocks. These reusable elements connect architecture definition to solution design and implementation planning. Phase B turns the architecture vision into a business operating model. The key question is not, what technology will we use? It is, how must the business work differently? For AI, that means defining capabilities such as governance, model management, and risk oversight. It also means mapping value streams from data intake through development and deployment to value realization. Architects then examine the processes automation will change and the organization needed to support them. Clear roles, accountabilities, and skills keep AI from becoming isolated experiments and make it part of how the enterprise delivers value. Capability maps move the AI conversation from tools to enterprise abilities. Instead of asking, which model should we deploy, architects ask, what must the business be able to do reliably? For Azure AI, that may include data onboarding, model governance, prompt management, security monitoring, and compliance reporting. Value streams then connect those capabilities to how value is delivered. Maturity levels help expose gaps. If compliance reporting is basic today, but the target is advanced, that becomes a clear investment priority. When AI enters an enterprise workflow, the process rarely stays unchanged. A manual knowledge search might become AI-assisted retrieval, but that also introduces recommendation review, approval, and exception handling. The organization changes as well. Someone must own the AI product, govern model behavior, manage data quality, monitor security, and confirm compliance. Existing roles may not disappear, but their responsibilities shift. Business architecture connects these changes early, so teams understand who decides, who reviews, who is accountable, and where risk is controlled before implementation creates confusion or resistance. Data architecture turns raw enterprise information into trusted, AI-ready assets. It begins by identifying the systems and repositories that matter for the use case: CRM, ERP, documents, logs, and knowledge stores. Then it defines how data is ingested, structured, mastered, described with metadata, and moved through pipelines. The critical step is governance, setting standards for accuracy, completeness, timeliness, lineage, classification, and access. Without that foundation, AI services may be fast, but not reliable. With it, applications can consume data that is explainable, protected, and fit for purpose. Reliable AI depends on disciplined data management. Quality rules prevent bad records, duplicates, stale values, missing fields, or inaccurate entries from shaping model behavior. Classification then tells the architecture how sensitive each data element is: public, internal, confidential, regulated, or PII. Once data is classified, governance controls can enforce the right owner, lineage, retention period, approvals, and access policy. This is not just paperwork. In enterprise AI, those labels determine whether a model can use the data, how prompts are handled, what gets logged, and what responses must be filtered. Phase C turns business capability needs into an application landscape. The key question is what each application should do and how it should connect. Some systems are reused, some modernized, some integrated, and some retired. The integration layer defines clean APIs, events, queries, and approval tasks between workflow tools, enterprise platforms, and AI services. For AI, this includes model endpoints, RAG services, content safety, and orchestration. The result is more than a system map. It is a set of application decisions that support process flow, data access, security, and user experience. Integration architecture is the connective tissue between business processes, enterprise data, AI capabilities, and operational systems. APIs expose capabilities in a controlled, reusable way, so teams can innovate without bypassing governance. AI services add reasoning, search, models, and safety checks where they create value. Workflow applications manage approvals, exceptions, audit trails, and coordinated process steps. The key design choice is the integration pattern. Real-time APIs for immediate answers, events and queues for resilience, batch for scheduled movement, and orchestration when multiple systems must act together. Phase D turns the target architecture into a technology foundation that can actually run. In Azure, this starts with platform basics: subscriptions, management groups, policy, and landing zones. From there, it connects identity, networking, compute, storage, security, monitoring, and DevOps automation. The key is traceability. Every technical choice should support a business, data, or application need, and satisfy non-functional requirements such as scale, resilience, security, cost control, and operability. Done well, technology architecture creates reusable building blocks, not one-off infrastructure, so delivery teams can deploy consistently and safely. Think of an Azure landing zone as the enterprise foundation underneath every AI workload. It defines where resources live, how subscriptions are organized, which policies are enforced, and how naming, tagging, monitoring, and shared services stay consistent. Networking controls the paths data can take, often through hub-and-spoke design, private endpoints, firewalls, DNS, and secure routing. Identity defines who and what can act, using Entra ID, role-based access, privileged access controls, and workload identities. Together, these foundations turn cloud deployment from a custom project into a repeatable, governed pattern that reduces risk. A target AI architecture is not only the model and the data flow, it also needs the operating foundation around it. Choose compute based on workload patterns, long-running services, event-driven functions, training jobs, or managed AI capabilities. Match storage to access needs from analytical lakes and relational data to document stores, blobs, and vector indexes. Then make security explicit through encryption, keys, secrets, private networking, threat detection, and policy. Finally, close the loop with observability and DevOps, so teams can monitor, release, automate infrastructure, govern changes, and learn from production behavior. To wrap up, phases B, C, and D turn the architecture vision into target architectures that delivery teams can act on. Business architecture anchors AI adoption in capabilities and organizational change. Data and application architecture define trusted information, services, workflows, and integrations. Technology architecture supplies the Azure foundation. Next, we'll express these decisions as artifacts and practitioner scenarios.